Hello and welcome. We are going to be working on 11.2a today, multiplying rational expressions. And remember, rational really just means a fraction. The only difference is its fractions are made up of polynomials, like on number 2 here. We call that a fraction, but it's actually called a rational expression because it's not just like 3/4. So our objective is going to be to not only multiply but to also simplify our rational expressions. So in order to be able to do that effectively, we have to do a little review here. A little bit of review on factoring, which is huge in this chapter, and also a little review on simplifying. So remember, when you're factoring, number one thing I ask myself is, can I take anything out? And if the answer is yes, I must do it. If the answer is no, then I try to unfoil it, or maybe if there's two terms, I look for a difference of squares. But we've got all our factoring techniques that need to come into play in chapter 11. The only way I can lead this problem and get 2x squared is to do 2x and 1x. I can end it in multiple ways. I can end it in 6 and 2 or 4 and 3, or if those don't work, 12 and 1. Remember to make that choice. First of all, a little sign analysis here. I know I'm going to need one positive and one negative. I also know I need to multiply and then add up to a 5. So when I first start looking, I look at 12 and I look at 2, and there's no possible way I'm getting a 5 out of those. I then reverse that, and I look at 4, and I look at 6. And again, no possible way to get that 5. So this matching is out. When I go to the next match, I've got 8 and 3, and I just know I've found it. With 8 and 3, I can get a 5 out of those, but without a sign difference, they add up to 11. So because I need them to add up to positive 5, the positive needs to win out, so I need that 3 to be negative. So now let's link this. On my outside, I have 2, and it was linked with that 4. So 4 is going over here on the outside, and on the inside would be the minus 3. Remember to check that. We can always FOIL. And in the context of chapter 11, we are going to be looking for some canceling. So it's our hope that there's maybe a 2x minus 3 or an x minus 4 somewhere else in the expression so that we can factor and cancel it top to bottom. So when I'm looking at number 2 and I'm being asked to simplify it, again, I go to the top and I ask myself, can I take anything out? And the answer is yes, a 2, because they're both even. So I divide a 2 out of 2x and I divide a 2 out of 6, and it leaves me with 2 times the quantity x plus 3. I'm now hoping that an x plus 3 is a factor of the bottom, because then they'll cancel. And I can see that that is indeed the breakup. So let the ones that are easy to factor help you with the other ones. Now, when I'm asked this question about excluded values, remember, I find those before canceling. So I look on the bottom and I say, well, what would make the bottom equal to 0? A negative 3 would make that factor 0, and a negative 3 would make that one 0. So I don't really need to list it twice. Negative 3 is what I'd call an excluded value. Now I go cancel. And my simplified answer is 2 over the quantity x plus 3. So that's review, and we should know how to do that. But remember our two words I've been saying a million times. We factor and we cancel. So moving right along to some new stuff, we're going to kind of build this in a system of a level system. Level 0 is what I would call it, is when we're multiplying fractions and we don't have any variables. That's what I mean by non-algebraic. Recall what you do for multiplication. You can cancel any factors top to bottom, and it's highly suggested that you do that. You can even cancel them diagonally. So when it says, what can I cancel? Common factors, top to bottom. So do I see a 2 living on the bottom? And I do. There's 1 living in the 8, so I'm going to divide that out. Do I see a 5 living on the bottom? And the answer is yes. There's 1 in the 15. Once I'm done, I multiply straight across. So it says, can I cancel diagonally? And the answer is yes. As long as you're going top to bottom, you can't go top to top, you can cancel. So some examples. That process will not change when I am now working with algebraic expressions or expressions that have variables in them. So when I go over here and I'm being asked to simplify this, I just start with the 2 and I say, do I see a factor of 2 living on the bottom? And the answer is no, so I leave it. Then I go to the x and I say, do I see any x's living on the bottom? Yes, even though they're diagonally, I can divide an x out of both of them. It'll leave, none of the x's will be left up on the top, but I'll have one left on the bottom. Is there anything in 12 that's living as a factor on the bottom? And the answer is yes. 12 is 3 times 4, and that 3 will cancel, or you can divide it out. Once you have it simplified as much as possible, you multiply straight across. 2 times 4 on the top gives me an 8. And 1 times x on the bottom gives me just an x. Now, if I were asked the excluded values for this one, which I'm not, but it's good to keep an eye out for them, I would say 0 is an excluded value because that would result in a 0 in the denominator. Number 2 looks like a mess, but it's actually very nice because it's already factored for you. So you take each factor and see if you see it living on the bottom. And I do. I see I'm trying to move the screen here. I see a 3 living in this 6. So I'm going to divide out a 3 and divide out a 3. P plus 1 is a factor, and it's living over here. Top to bottom can be canceled. P minus 2 is a factor, and it's living over here. So really nothing's left on the top but a 1. Everything canceled. On the bottom, I have 2 times 2, which is a fourth. Notice how clean that got. The simplification gave me 1/4. It means no matter what P is, I get a fourth out, unless P is an excluded value. What are the excluded values here? 2 and -1. I didn't ask that, but kind of keep them in mind just in case it does. Number 3 on the top of the page. Again, not so bad because they have it factored for you. It looks intimidating, but that one is actually way easier than number 4. So we're kind of going up in levels here, and it's going to mimic how your worksheet goes too. So over here in the how, what do? I cancel common factors, top to bottom. Keep in mind that I always need to factor first where necessary. So number 3, do I see a 7 living on the bottom? No. Do I see n's? And you might be saying, I see a bunch of n's. But keep in mind, we're looking for a factor of n. This is an n minus 3 factor, an n plus 4 factor. And although it appears that they have n's in them, they are parts of a sum, not of multiplication. So the only n that I can cancel out is this one with that one. So you can't go in and cancel parts of parentheses. I'm going to repeat that. You can't go in and cancel parts of things that are in parentheses or connected with pluses or minuses, as we've discussed before. So I do see an entire n plus 4. I do see an entire n minus 3. So what's left on the top? A 7 times an n. And on the bottom, I have an n plus 8 times an n plus 6. And nothing cancels because these n's are linked to the plus 8 and the plus 6. For example, if n is a 5, there is a 5 on the top, but there's no 5 on the bottom. This would be a 13, and this would be an 11, neither of which have a 5 in them. So be careful when you see that n of thinking it's a factor. It's not if it's connected to a plus or a minus sign. One of the biggest mistakes with this section is people lose things in the canceling. So you might want to make sure that you really neatly find everything that's left and cross out carefully, like don't accidentally cross off across things. So you got to be a little careful in all your slashing. Your work's going to look like a mess. You're going to factor things and then you're going to basically systematically go wipe everything out. So the next one, number 4. I've got 7n on the top, which doesn't factor, so I'm going to leave that. On the bottom here, I've got n's in both terms. I've got a 4 in both terms, but even bigger than that, I have an 8 in both terms. So I'm looking for the biggest thing I can factor out of there. Now, keep in mind, you cannot cancel this n with this n, because that one's part of a subtraction problem on the bottom. I am going to be able to cancel it over here, but I'm going to get everything factored first. So out of this bottom right here, I'm going to pull out the greatest common factor of an 8 and an n squared. And when I divide out an 8, I get a 3. And when I divide out n squared, I get an n left. I've got a minus. And then when I divide an 8 out of 64, I get an 8. And when I divide out n squared, I won't have any left. Now, what I'm hoping is living on the top is a 3n minus 8, so that they'll cancel. So when I'm looking to factor this one, I'm thinking maybe a 3 comes out, and I'll have 3n minus 8. Keep in mind, your whole point of factoring is so that you will be able to cancel. So you probably will be able to. So there everything is strung out in all its factors, and now I start slashing things. Do I see a factor of 7 on the bottom? I do. Do I see a factor of n on the bottom? I actually see 3 n's that could cancel, but I can only wipe out one of them. I've got 2 here that are factors and 1 over here. I'm just going to head across, and that whole 7n wipes out. Do I see a 3 on the bottom? You might say, yep, I see one right here. But that's not a factor. That's part of a difference. So the 3 can't cancel. However, this entire 3n minus 8 can. So when I'm all done, I get a 3 over 8 n squared. Let's discuss if you were asked the excluded values for this problem. You would be tempted to go right to your answer and say, oh, n can't be 0, and that's one of them. But remember, when we're doing excluded values, we find them before we've canceled. So n can't be 0, but it also can't be 8/3. So you've got to be careful that if you're asked excluded values, you do them before you cancel. So over here, this one looks like you might want to just go slashing stuff. You've got 9s and 54s and r's kind of everywhere. It looks like someone just kind of puked up a bunch of 9s and a bunch of r's. However, you can't cancel right away because it is not factored. So again, we're going to go factor it. However, let's outsmart it a little bit, because you'll notice that the top left and the bottom right are identical. So if I factor them, they're going to factor into the exact same factors. I've said factor a lot, haven't I? And it's all going to cancel. So if you notice that this entire chunk goes with this entire chunk, that's good to spot, because otherwise you're going to waste some time factoring and it'll all cancel anyway. However, the bottom left and the top right do deserve some consideration, because I can't cancel them. They are not identical. They need to be factored first. So I'm going to leave that 1 on the top, and I'm going to look at this and pull out a 9 and an r, leaving me with an r plus 5. On the top, I'm going to factor out a 9 and an r, leaving me with an r plus 1. Now when I go cancel common factors, the 9 with the 9, the r with the r, and I'm left with on the top r plus 1 times 1, which doesn't do anything, over r plus 5 times 1, which doesn't do anything. You might be tempted to cancel those r's off, but again, they are not factors. They're parts of a sum. So that one's done. And last one up here. Again, same question. Why can't I cancel those n's off? And the answer is it's not factored yet. So, but once again, if you pulled a 6 out of the top here and a 6 out of the bottom, both of them would be 6 times n plus 1, and it'll all cancel. These are identical, so it's helpful to notice that because it saves you a little bit of time. So really, I have a 1 over n plus 9 with the left rational expression times, over here you might say, well, I can't pull anything out. You can't, but that doesn't mean it can't factor. Furthermore, what am I hoping is living in there? and n plus 9. That might trigger your brain to say, oh, 9 and 3, there it is. Those will multiply to equal negative 27, as long as one of them's positive and one of them's negative. So you can sort that out. And you'll get that n minus 3 that you were hoping for, because again, our whole point of factoring is so that we can cancel entire factors top to bottom. So this whole expression, which was very ugly, ends up being n minus 3. What's the power in that? The reason for being able to simplify is because if I were to say, hey, what do you get if n is 10? The person who takes out their calculator and does 6 times 10 plus 6 and writes it down and then puts a 10 here and squares it, no, it's going to take a long time. Where if I go to the simplified version and say, what's the answer? Answer 7. So there's a huge benefit to being able to simplify because it makes your math work so much easier. So let's summarize this. To multiply rational expressions, remember, factor first, factor first, okay? Once I've factored, I get to cancel anything top to bottom, even diagonally. Then I multiply straight across. And that's the end of 11.2a. Your assignment is, per the same drill we've been doing, you're going to work in your packet. You're going to do the 5 through 28, skipping the circled problems. All work on a separate sheet. And some of those I've done already. So this was number 28. I numbered them on here. So if I've done it already, you do not need to redo it. All right, so have a good one. Over and